Hello friends, in this tutorial we are going to learn how to write NS2 code. So this is the first experiment that you are having in your syllabus. So what is the question? The question is implement a point-to-point network with 4 nodes. So there are 4 nodes. So you need to create a point-to-point network in between them. And that links should be duplex link. And you need to analyze the network performance by varying the queue size and bandwidth. Okay. So first thing, you need to create an network simulator instance. So how to create that? The command for that is you need to write set ns space, okay, then open the square bracket, new simulator. Okay, so you are creating a new instance, okay, and that you are representing it by ns. So you are creating a new instance of a simulator. So and the name of that is ns. Okay. So here majority of the students will commit mistake by writing this S in lowercase. So always remember simulator is in upper. Okay. So after writing that, so we need to create a trace file. So how to create the trace file object? So set tf. So tf I'm taking a short form of trace file space square bracket. Okay. And I'm opening a file called as s1.tr. Okay. And I'm opening this in write mode. So what I'm trying to tell my simulator that, so I'm opening a trace file named as s1.tr. Okay, and this is the reference of that trace file, that is tf. Okay. So next, what I need to do is $ns trace all $tf. So here what I'm trying to tell my like simulator that, so in $ns, that is in this ns, whatever happens, like the packet is generating, from which node it is generating, from which like destination it is going, which path it is following, so that all will be traced. Okay, that is trace all, and I'm storing that in tf. So tf is internally I'm linking it with s1.tr. Okay. So now next is I need to create an animation also. So why I need animation? Because the to have a look from where the packet was generated, it will show me an it will show me the whole scenario in terms of animation. So now for that command is set nf, okay, network animation. So set nf space square bracket. Here also I'll open a file called as s1.nam. Again I'm opening that in write mode. So here in previous case I had opened a trace file to store all the traces of the packets. So I'm opening an nam file called as s1.nam, and nf is in and nf is the instance of it. Okay. So here also I need to specify what animation should be stored in s1.nam. So here the same procedure $ns, okay, nam trace all $nf. So here what I'm doing is in $ns, whatever packets will be generated should be traced. Nam trace means should be nf is internally linked with s1.nam. So your s1.nam will be having all the animations animations of the packet generated, animation of the packet dropped, okay, will be stored in this. So this video might be a bit lengthy since this is the first code. From second and third code, this will be specific for that. Okay. So now we need to write a finish procedure. So how to write a finish procedure? PROC. Okay, this is the procedure finish. So I'm giving the name as finish to my finish procedure. Open a flower bracket, close a flower bracket, and open once again a flower bracket. Okay, should give a space between this. So here I am writing the finish procedure. So finish procedure is called whenever your program is started, and after ending that your finish procedure, this procedure will be called. So in this procedure, what we do normally, we normally clear all the data that we have stored in NS. Okay. In this NS, whatever packet was generated, everything will be clear. Okay. So how to do that? First, we'll define the global variable. So now, which are the global variable that we have created? It's NS, TF, and NF in $NS plus trace. So I'm flushing each and every trace. I'm closing the file, that is $TF and $close $NF. Okay. So these files that I had created over here, I'm closing here in the finish procedure. Okay. Then after closing, what I'm doing is I'm executing exec is a command. I'm executing which file? I'm executing a NAM file. Okay. NAM, I'm executing. This command says that I'm executing a NAM file. What is the NAM file name I'm executing? This is s1.nam. s1.nam. The file that I had created over here. Okay, I'm executing that. So as I had said before, what is s1.nam? What it will have? It will have the animation from where the packet was generated, where it is reached, and from where it from which node it got dropped. Everything will be recorded in this. Okay, and we need to place and over here. So execute NAM file. So what is the NAM file name? s1.nam, and we should add it at the last. So next we will type it's 0. Then we'll close this flower bracket. That the flower bracket that we had opened, we are closing it over here. So finish procedure we have completed. Next, we'll go for creating the nodes. So here what they have said, we need to create 4 nodes. Okay. We need to create 4 nodes. So how to create 4 nodes? Set n0. So this is my node number 1. So I'm writing it as n0. Okay, a square bracket. So what is it? It's a node. So $NS node. Fine. So I have created one one node, that is set n0 $NS node. I'll copy this because I want 4 nodes, right? I'll paste this 4 times. So I have pasted this. I'll change the naming of the nodes. So first was n0, next will be n1, next will be n2, and next node will be n3. So I have created total 4 nodes. So after creating the 4 nodes, so what they have said in the question, they have said you should have a duplex link between them. So I should have a duplex link between them. So how to create duplex link? $NS duplex -link. Okay. So the duplex link is between which node? That is $N0, node 0, and $node 1. So the duplex link is between $N0 and $N1. So we need to specify the bandwidth next. So what is the bandwidth? I'm giving 1.5 megabits per second. Okay, with 10 milliseconds of drop tail. Okay, drop tail. So here you need to observe that in drop tail, D and T are capital. Okay, D and T are capital. So I have created I have created link between N0 to N1. Okay, because since it is a point-to-point network, next I'll create a link between N1 to N2. Next I'll create a link between N2 to N3. Okay, the steps remains the same. I'll copy this and I'll paste over here. So I'll change this to N1 to N2, and here N2 to N3. Okay, so I have created a point-to-point network. So they have also said us to create a queue size. So we need to create a queue size. How to do that? So $NS queue limit, QUEUE hyphen limit. So queue limit Between whom? $N2 and $N3. So we are creating a queue limit between here N2 to N3. N2 to N3. We are creating a queue limit of how many packets? 5 packets. So 5 packets will be in the queue. So now we need to attach the agent for it. Agent in the sense application layer protocol and your transport layer protocol. Whichever we are using, we need to attach over here. Okay, so they have not specified over here. So either I can take TCP or I can go with UDP. So first we'll see with TCP. So how to do that? So we need to attach set TCP. Okay, set TCP hyphen new agent slash TCP. So here you should observe that your agent A is capital, okay, and TCP is capital. So here is a mistake. So set. So now I have created a TCP agent. So next step is to attach this TCP agent with any one of our node. The command is $ns. It should be on the next line. $ns attach agent ACH hyphen agent attach agent with $N0 and $TCP. So here what I'm doing is I'm attaching my node 0 with TCP. Okay. So that means node 0 will generate a packet of TCP of the transport layer protocol, and it will be the source of that is node 0. From node 0 it will be generated. So next I need to create the destination also. So for that, set TCP sync. I'm writing TCP sync. Okay. New agent slash TCP sync. So now I have created a TCP sync. That is, this is the destination. So I have given a reference instance of name as TCP sync. So new agent TCP sync. So here you should remember that A is capital, TCP is capital in TCP sync. So next we need to attach this with any one of the node. So $ns, the steps remain the same. Attach agent, okay, $N3. So I'm attaching with that N3, okay, and $TCP sync. Okay, so now this is my source, that is N0 is my source and N3 is my destination. So I attach N0 with TCP and attach N3 with TCP sync. The packet generated from node 0 will be going to the destination N3. So I have created the transport layer protocol. So now I need to create an application layer protocol. Okay. For TCP, we know that application layer protocol is FTP. Set FTP, okay, new application slash FTP. Okay, new application slash FTP. Here you need to make a note that A is capital and FTP is capital. Close the bracket. So now you need to attach this FTP with TCP. So $FTP attach agent with $TCP. So now I have attached this TCP with FTP with TCP, and TCP is internally attached with N0, which is our destination. So next I need to connect $ns connect $TCP with $TCP sync. Okay. So here I am connecting my TCP with TCP sync. That means this is the source and this is the destination. Now we'll start process $ns at 0.2 second. We are making FTP So at this says that at 0.2 seconds in NS, in the NS instance, we should start our FTP. I'll copy this code and I'll make some changes like this. At 2.5 seconds, at 2.5 seconds, I want my FTP to stop. If you want, you can add a few more lines of code. At 2.8 seconds, 2.8 seconds, we will start our FTP once again. And at 3 seconds, we will stop our FTP. 3.0, can include it, will stop. STOP. Here I have made a mistake. STOP. Done. So next, what I'll do at $ns at 3.1 second, I am calling a procedure. Which is that procedure? That procedure is finish. At 3.1 second, I am calling finish procedure. So my program will come to this finish procedure. It will execute my NAM file. Then it will clear all the trace file. So now what I'll do is $ns run. So this is my code. As we have written the code, so how to execute it? Just open the terminal. So there are two ways. First, you can go to this show applications, and here you can type in terminal. So here we have terminal, or else you can type in terminal. If you type terminal, then terminal opens up. So here my terminal has been opened. So next, how to run it? So first you should remember that you are in desktop. So your file is stored in desktop. So how to run it? First you need to go to desktop. So CD space desktop. Remember D is capital. Desktop and press tab, enter. So now you are in desktop folder. So you need to run 1.tcl. How to run 1.tcl? Type in the command ns space file name is 1.tcl. So if I run this, so you can see here. So this is my network layout where there are 1, 2, 3, 4 nodes and they have connected with the link, duplex link. So if you want, you need to run it. So you can run, click on this and you can run it. So now you can see the black color thing. These are the packets, and the small color black color things. These are the acknowledgement packets. So the source is from 0 and the destination is 3. So you can see we have the small packet. This is because we are using TCP. So TCP sends an acknowledgement. So that is why these small packets are going towards the source, telling that it has been successfully reached at the destination. Okay. So now in exams you may be said that vary the bandwidth. Okay, vary the bandwidth and check the number of packets drop. So open your code. So once you open your code here, so you can increase the bandwidth. So now I'm increasing the bandwidth to 15 Mbps. Okay, and the queue limit I'm giving it as 3 or 2. So this I'll keep it as same. Okay, sorry, 1.5. So I'll save it. So likewise, you can change the bandwidth between the nodes and run it once again. Go to the terminal once again. Just press the upper arrow key. So you'll find ns1.tcl. Press enter. A window will pop up. So now here you can see here the window has popped out. So this is your network where they have connected by a link-to-link connections. So you can, if you hover your mouse over here, so you can change your layout as well. So see, I can change my layout. So now we'll press the start button. So it has been started. So you can see packet have started to flow. The packets have started to flow. Let me see whether there will be a drop of the packet or not. I hope there should be a drop of the packet. Can I fast forward it? So there was no drop of the packet. So if I open the s1.tr, so this is my trace file. So now here column number 1 will show you dropped packets. Okay, you can see this column 1, 2, this column number 1 where it is plus minus r plus minus r. So this column represents the like type of the packet, whether it was received or it was sent, whether it was in the queue, everything. If it's a dropped packet, so then instead of r here it will be d. Okay, since we have no packet dropped, so it is plus r only. So this was your explanation about your first code NS2. So let us meet in the second video where we'll explain second code, that is of NS2. Okay. Thank you guys. Thanks for watching.